The terms we're going to talk about is essentially we're going to talk about is molarity. All right, molarity is a measurement of concentration, and molarity is a measurement of moles of solute per liter of solution. Solute is the substance being dissolved. Solvent is the substance doing the dissolving, and those two together make up our solution. So if I were calculating molarity of 80 grams of sodium hydroxide in 100 mils of water, I would need to find and convert my sodium hydroxide to moles and convert my water into liters. Now, if I'm a solid and I completely dissolve in water, that doesn't change the volume. The volume of the water is the volume of my solution. We'll talk more about it in future chapters where we mix things like two liquids together and things like that. Well, we know how to get our grams to moles. We need to use the molar mass. The molar mass of sodium hydroxide, 23, 16, and 1 is 40 grams per mole, and 1 mole of sodium hydroxide. Okay, 40 grams sodium hydroxide. Cancel out, and we get 2 moles. Our liters, move the decimal 3 to the left, we have 1 liter. So to find our molarity of this solution, it would be 2 moles of sodium hydroxide over a liter of solution, or our molarity would be 2, what we would say is 2 molar, okay, or just 2 big M, like so. And that tells us that roughly for every liter of this solution we have 2 moles of the sodium hydroxide dissolved in it. Okay. So, if someone said to you, hey, go make up this solution, I need you to make up 500 mils of 3 molar sodium chloride. How the heck am I supposed to do this? All right, well, the 500 mils, I know that's how much water I need. Okay. So I know my volume of my solution is 0.500 liters. And I know my molarity is 3 molar. So just like your density, there's the molarity triangle. Okay, moles here, molarity, liters. Cover what you're looking for, and that's how you find it. So cover up moles, multiply molarity times liters. And I would know I would need 1.5 moles of NaCl. But the problem is, if I were trying to tell somebody to make this solution, they're not going to know what moles are. They can't go down to the lab. If they have no chemistry experience, they don't know what moles are, but they could weigh out grams. So if I wanted to explain to somebody how to make this solution, I would then take my 1.5 moles of sodium chloride. For every 1 mole of sodium chloride, we do the mass, which is roughly 58.5 grams. And let's see here. Got to bring up a calculator. 58.5 times 1.5. I mean, it's going to be roughly 90. Yep, 87.75. So 87.75 grams. All right. And that's for every part of our solution. So if I wanted to explain it to somebody, I'd say, hey, take 87.75 grams of sodium chloride and add it to 500 mils, or 0.5 liters, but we'll do mils, 500 mils of distilled water. Okay. All right, questions on how to find molarity? Cool. Cool, cool, cool. All right. Well, what can we do? Let's say, all right, so let's say we're in a lab and we need this 3 molar solution, right? So we make it up, we put everything together and make up said solution. But, okay. We look ahead and now the experiment asks for and says, hey, you need now to use 100 mils of 1 molar NaCl. And you're like, okay, well, I just did the math on this one. Let me go do this. But let's say we're out of NaCl solid. We're out of NaCl solid, so I can't weigh it out and add it to the water. What I can do is take a more concentrated and turn it into a less concentrated. So think of it this way. The example I always use is if you had a glass of sweet tea or some really sweet drink and it was filled to the brim. Now you wanted to drink it, but you take your first sip, it's too sweet, but you still want to drink it. What are you going to do? You're going to add some water. Well, if it's filled to the brim, you can't add water. So what are you going to do? You're going to dump some of the sweet drink out and then add some water. You're going to dilute it. And that's what we're going to do here, but we can't use the word some and some. We actually have to figure out the amount. So the formula is this. MCVC equals MDVD. You might see it as M1V1 equals M2V2. I like using C and D because C stands for concentrated and D stands for diluted concentration. So I've got a concentrated solution. I've got 3 molar. I don't know how much I'm going to pour out. That's what I need to figure out. I do know I need 100 mils of 1 molar. So I know my diluted concentration. I know I need 100 mils. Okay. So we're going to divide each side by 3. We're going to multiply these together and divide by 3. And we're going to be left with the volume of the concentrated is 33.3 roughly. Okay, so that's telling me that I need to dump out 33.3 mils of the concentrated solution. Okay, but I need 100 mils total. The other mils come from water. So what you do is, to find your volume of water, you take the volume of the diluted minus the volume of the concentrated. So 100 minus 33.3, and you need 66.7 mils of water. Okay? So if someone said, explain how you would dilute it, you would basically tell them, I'm going to take 33.3 mils of the 3 molar and add it to 66.7 mils of water. And if I do that, I should have 100 mils of 1 molar NaCl. And this is known as our dilution formula. So on the exam, I'm going to probably ask you to make a solution. I'll probably ask you, not on this exam tomorrow, but on our next exam, I'm probably going to ask you those different things. Okay. Now, where is this extremely effective using molarity and things like that? Okay. Chapter 4 is going to get into solution chemistry. All right. But let's say we have a reaction. I don't know where my black. Here it is. Okay. We have a reaction of let's say, sodium sulfate, a solution of sodium sulfate, and we react it with, yeah, I think I did this one last time, but we'll stick with it. Barium nitrate. And we're going to get out, and you're going to learn this in the next chapter, but you're going to get out barium sulfate, which is a solid, plus, I got to just look and see what ions we had, sodium nitrate. And to balance it, I need a 2 in front of there, and we should be balanced. But here's the deal. With aqueous solutions, when we were doing theoretical yield, previous lecture, we gave you grams to start. To find the limiting reagent, the thing I posted online for you to watch, find the limiting reagent, find all of that stuff. It was all in grams. Well, when they're aqueous solutions, we really don't use grams. We're really usually told, okay, I'm going to take 3 molar and 30 mils of the sodium sulfate and react it with 2 molar and 50 mils of the barium nitrate. Now, don't freak out, okay? Here's our map again for the 100th time. Grams of what I know, okay? So what I know, grams. Molar mass of known, grams on the bottom, 1 mole on top. Okay. Mole ratio. What I know. What I want. And the molar mass of what I want. With the mole on the bottom and the grams on top, right? And we plug the grams in and we worked it out and we find our limiting reagent. We do all of that. Well, here's the difference with aqueous solutions. They didn't give us grams. They gave us this. So if they gave me a molarity and a volume, what could I figure out? Well, if they gave me a molarity and a volume, I could figure out the moles. And all I'm doing is, once I figure out the moles, is starting here. So instead of finding the grams and working it to moles using the molar mass, I'm going to use the molarity. So it's nothing new. It's just this added to this. So for my sodium sulfate, I've got 3 molar. I've got 30 mils, which is 0.030 liters. For my barium nitrate, so this is sodium sulfate. This is my barium nitrate. I've got 2 molar and 0.050 liters. All right, so this would be 0.090 moles of sodium sulfate. This would be 0.1 moles of barium nitrate. Okay, so I know my moles, so I'm technically here right now. To figure out my limiting reagent, I convert it to moles of product. Pick a product, doesn't matter. The relationship for each of them is either 1 to 2 or 1 to 1. So let's just say barium sulfate. So for every 1 mole of sodium sulfate, I should get out 1 mole of barium sulfate. Cancel out. For every 1 mole of barium nitrate, I'm using my stoichiometric coefficients as the ratio, like the video I uploaded shows you. 1 mole of barium nitrate gives me 1 mole of barium sulfate. They cancel out. And let's take a look here. 0.09, so I'd have 0.090 moles of barium sulfate, because it just so happens it's a 1 to 1. Down here I'd have 0.1 moles of barium sulfate. So this is my limiting reagent. So the concept is not new. It's just how do I get to the moles this time? So in our last video, they gave us grams. We used the molar mass to get to the moles. This time I'm going to use molarity and volume to get to my moles, to figure out my mole ratio and limiting reagent. All right, questions on this? Let me pull this down a little bit so you can just see it there. Questions on this? Now, this used to be the end of chapter 3 in the older edition of this book. They moved it back to chapter 4 because they mixed it in and said, well, if we're going to talk about molarity, we're going to talk about dissolved in water, so we should talk about it in aqueous solutions instead of talking about it in the mole. So just so you know, this is really like end of chapter 3, beginning of chapter 4 stuff. And therefore, the homework on it would be page 197. .22 to 4.25. .28 and 4.29. Okay. So that would be the homework that deals with molarity.